No, okay. I'm Vincent, and my topic is drinking by sea snakes from oceanic freshwater lessons at first rainfall ending after the seasonal drought. And I first introduced reptile drinking behavior in arid environments. Uh, uh, okay, no, because they are in arid environment, so they have to endure uh, long-term drought. And for terrestrial snakes, they emerge to drink from temporary rock pools or even flatten their scale to harvest droplets from rain. And for amphibious snake, they leave the ocean to drink from land freshwater pools after droughts. But for pelagic snakes, they can go to land, and how they survive from a long-term drought. Traditionally, many marine vertebrates like turtles and sea snakes are thought to live independently from fresh water because of their salt glands. But the truth is, their salt gland is too small to process large amount of salt. That means they can't direct drink seawater. This is Hydrophis platerus, also called yellow belly sea snake. And this is the only pelagic species of squamate reptile. And squamate means they have scales on their skin, like this. And it is also a squamate reptile. So the Hydrophis platerus, they only live in the ocean and drifting with currents. They depend on freshwater and dehydrate at sea during the periods of drought. Rainfall forms freshwater or dilute seawater lands during intense precipitation. And rainwater is, because rainwater is less dense than seawater, so they float on the surface of seawater, and like this, and form the freshwater lands. And the only source of freshwater for pelagic snakes is freshwater lands. And the purpose is to investigate the drinking behaviors of pelagic sea snakes at the transition from seasonal drought to wet season, and confirm them if they are rely on freshwater lessons to rehydrate. And the hypothesis is the pelagic sea snakes dehydrate at sea during the dry season and rehydrate drinking from freshwater lenses from rainfall of seawater of wet season. And the study was held in Costa Rica. This place will last a seasonal drought 6 to 7 months. And the gray part area on the figure is where they catch the snakes. And they use both direct observation and satellite data to track precipitation and catch the wet season. And they captured the sea snakes using these handheld deep nets during the sea snakes show float and wave posture. And because they just experienced the drought, so they need to drink water, so they are easy to catch. And in total, get day night snakes over a night. And they use, at the same time, they use portable salinity refractometer measure the salinity of water, measuring how much water a sea snake drink. So after they were captured, they were sending the cooler and to the lab. After before they waited, they have to lie on the dry towel until the skin was dry to touch, to ensure they measure the accurate initial body mass. And then they have to measure how much fresh water they drink. So after they measure their initial body mass, they will place the snakes in a container with fresh water for 20 hours and quantify the fresh water they intake by body mass increase. And they use tail clipping to ensure they won't catch same individuals where they were sampling. And the picture, the XY axis is days of sampling. So total is 8 days. And the y-axis is salinity, sea salinity. So we can see the heavy rain occurs between day 2 and day 3. And this also shows the beginning of the wet season. So the wet season is after day 2, day 3. And at this time, surface salinity decrease because rain coming. And this y-axis is percentage of drinking. So before rains, there's about 80% of sea snakes drink fresh water immediately after they were captured. And it dropped to 13% by day 8. This shows they were drink the rainfall before they were captured. And this is the percent of body mass drunk. So the black dot present the average value, and the lines present the standard error. And the figure shows there are no significant correlation between body mass and the amount of water sea snake drink. And the body mass data is from their initial weight. So we can see the mean size of drinkers is lower than the mean size of non-drinker. And based on this, and based on the data and the surface to volume ratio, they suggest the small individuals are more sensitive to dehydration than the larger one. This is my conclusion. Hydrophis platypus dehydrates during the seasonal drought, and they rely on freshwater that is formed by rainfall for rehydration.